What's up, nerds? My name is Alec Loftus, and today we're going to talk a little bit about radiation damage. But you see, before we get too deep into radiation damage, we first have to look into the different types of radiation. The first type of radiation we will be talking about is non-ionizing radiation, and that is when energy moves around a particle but does not permanently move it or displace it from its initial space. This is radiation like that from a microwave. The other type of radiation we are going to be discussing is ionizing radiation, and that is when a force permanently displaces an atom from its initial space. An example of this would be gamma radiation. For the purpose of this discussion, we will be talking exclusively about ionizing radiation. Hey, come check this out. So, another form of ionizing radiation is UV radiation damage. And an example of that is, let's say you take a rubber band, which is normally stretchy, and you leave it in the sun for a long time. It may discolor, but another thing it will do is become brittle. And that is an example of how it has been damaged by the UV radiation from the sun. Whew. However, on the contrary, materials like ceramics and metals are largely unaffected by ionizing radiation from gamma rays, X-rays, and, believe it or not, UV radiation. However, there is another type of radiation that does affect these materials. In the mirror, singing in the shower. Ah! Oh my gosh, you scared me there. And you're right, we almost forgot to mention the last type of radiation damage. Neutron radiation damage, which affects both ceramics and metals. An interesting thing that neutron radiation damage will do to metals is an initial sample will actually be enlarged by up to 20% inside of a reactor. And this can cause problems when designing reactors because obviously you don't want your materials changing by that much. Thank you so much for tuning in and learning about radiation damage with me. Tune in next time to learn more about your mom.